So let's do a little bit more complicated unit conversion problem. We'll pick one that takes a couple of steps. Sometimes if you don't know your conversion factor that goes directly from what you have to what you want, you might have to follow a little roadmap, right? Kind of see, well, I might not get all the way to the end point, but I can get to something more useful, and then I can take another step and get to what I actually want. So to do this one, and to kind of hopefully help you figure out that this works well for things you're not as comfortable with, I'm going to do something that there's no way you're familiar with because it's chemistry stuff with moles, right? So if we deal with something like oxygen, right, O2, 1 mole, which is a counting unit, that's kind of like a dozen sort of thing, 1 mole of oxygen equals 32.00 grams of oxygen. That's a different number for every element. And it has to do with how big each one is. The bigger they are, the more 1 mole of that will weigh, right? So you can get these off of the periodic table. This is called a molar mass, right? So you just hear that term, molar mass. And then we could also convert from moles to an individual count. And that is the same for every element. So here, 1 mole of oxygen is 6.02 times 10 to the 23rd molecules of oxygen. Molecules of oxygen. I can't spell. I can do chemistry, but spelling is hard, right? So here's 2 things we're not real familiar with, but let's say you've got an amount of oxygen that you know the mass of. Let's say you know you've got 50 grams of oxygen, and I want to know how many molecules of oxygen that is. Well, I know it's going to be a whole bunch because the individual molecule count is a lot, right? Even in a drop of water, there's trillions and trillions and trillions of atoms, right? So if I kind of think of a pathway, I could change from grams to moles, and then I could change from moles to particles, right? Molecules is just a word for particles. So I would say I'd let my units guide me. Let's change colors here. I'll use this red conversion factor first because I let my units guide what I'm putting where. So I have grams here, so I'm going to start with grams. And I'm going to say, well, for every 32.00 grams of oxygen, it is 1 mole of oxygen. Right? That's this red one. Now my grams have canceled, and I have moles of oxygen. So now I can do a second step. Maybe try and set it up ahead of me, where I'm going to say 1 mole of oxygen, and I'm going to put that on bottom so that we're diagonal again. 1 mole of oxygen for every 6.02 times 10 to the 23rd molecules of oxygen, right? So I like to kind of use this pathway where I'll write out my given. I never give myself enough space, but a little pathway so I can see where I'm going, right? So then my moles of oxygen cancel out. See, we were diagonal. We're diagonal. We multiply by everything that's on the top. We divide by everything that's on the bottom. Again, for the calculators, if you're using the ones we've got here at school, right? If you're using the ones we've got here at school, you do 50 times 6.02 and then use that 10 raised to whatever power. We need to put that in parentheses though. So parentheses 6.02 times 10 to the 23rd. Then you have to hit the over button and end parentheses so that you look like that. Learning how to use the tools is a helpful thing to do, divided by 32. And that's going to give us 9.4 times 10 to the 23rd. So that is 9.4, right? Yeah, 9.4 times 10 to the 23rd molecules of oxygen. Right? So we can do a little bit more complicated problem. So we're at almost 4 minutes. Let's try and do one more complicated problem. This time, we'll go the other direction. I want to know what 100,000 molecule or atoms, we'll do atoms this time, atoms of carbon. How much does that weigh? Well, this one I can actually still use because the count is the same. I'm just going to say 1 mole of carbon equals 6.02 times 10 to the 23rd atoms of carbon. That's true for that's count. That's like a dozen, right? 12 is true for a dozen all the time, but a dozen eggs weighs different than a dozen cars. So this one I wouldn't be able to use here. This one I would have to change. Can we see that part okay? To 1 mole of carbon is 12.01 grams of carbon. And you can get these numbers off the periodic table when we get to that. We're not really to that yet. Right now, we're just kind of using this as a complicated way of doing it, right? Or a complicated problem. So now again, I'm going to let my units guide what I do first. I want to go to grams over here. So I'm going to kind of do backwards of what I did before. I'm going to go from atoms to moles and then from moles to grams. So I've got 2 steps to do that. So I'll do 6.02 times 10 to the 23rd atoms of carbon for every 1 mole of carbon. That's this one. So now I've changed to moles. Moles is a count, and a count with a specific amount of particles, which will weigh a specific amount, right? So I can go either direction here. So then 1 mole of carbon on bottom, and what I want is grams, so 12.01 grams of carbon. So again, grabbing my calculator, 100,000 sounds like a lot, right? So we type in 100,000. Did I type that in right? See, I should have just used scientific notation, and then I could have counted my zeros easier. Times 12.01 divided by 6 and remember, put it in parentheses, 6.02 times 10 to the 23rd. So you got to put it in parentheses, especially when you divide. If you've got a calculator that doesn't bunch them together, which like this calculator will bunch them together for me automatically, this one doesn't. So you have to know how to use your tools, right? And I do that, and I get 1.995. So let's just round it to 2 e, or times 10 to the negative 19th. Some people's calculators will look like that. Some people's calculators will look like this. We do want to recognize that's telling us the same thing there. 2.0, I should make my decimal point easier to read there. 2.0 e negative 19, that's times 10 to the negative 19th, or 2.0 times 10 to the negative 19th written out like that, right? So hopefully that helps on those slightly more complicated ones.